Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, finding the limit of your function at a point. Now, if new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 12th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 4 parts. So leave a like, smash subscribe, and let's get started. So today we're going to be talking about how to find the limit of your function at a particular point. Now on the channel, we've already talked about the basics of limits and how continuity affects your limits. And we're going to be putting that knowledge together to really understand why we're evaluating these functions the way we are. Now the first thing you want to do when you're asked to evaluate a function at a particular point is to check for continuity at that point. Now the reason you want to check for continuity at that point is because a continuous function is going to have its limit equal to the value of the function at that point. Now in my previous videos, I tried to stress over and over and over that the limit of a function at a particular point does not depend on the value of the function at that point. And that is still true. I'm standing by that. However, that's because the limit doesn't have to equal that value. And I don't want you to get into the trap of thinking the limit is always going to be the value. Sometimes the value is different, sometimes it doesn't exist. However, for continuous functions, that's not going to be the case. Continuous functions will always have their limit equal to the function value. So check for continuity, at least at that point. And to do so, all you have to do is take your point and plug it into your function. And when you do this, you get one of 3 possible outcomes. The first being a number. You get a number, and this is acceptable. This means that you're done. You found the limit. However, you won't always get a number. Sometimes you get something that looks like this, 0 over 0. And this is going to be your indeterminate form. Your indeterminate form. And that simply means you're not done. You got more work to do. And lastly, you may get something like this, where you have some number over 0. And this also may mean that you have more work to do for a different reason from this, but it also may mean you have more work to do in some cases. Sometimes your teacher will say this is enough, and you can say that the limit doesn't exist. But in other cases, you have to go a little bit further. So we're going to cover both of these a little bit later on in this video to show what work is needed to find a limit if it exists. But we're going to first start with when you have a number as an outcome, an acceptable number as an outcome. How does that work? We're going to jump into an actual example of getting something like this. Now I just said in order to get that first outcome of just getting a number, you really have to be continuous at that point. So we're going to be looking at some examples of continuous functions in which all you have to do is plug in your number. Now these are not going to be all the different types of continuous function that you run into, but this gives you an idea of the different types that you may run into. The first being just your polynomials. You can have some fractions like this, or you can even have constants. Now constants, you don't really have to plug anything in. However, it's a continuous function and you can easily find its limit. So if you had this polynomial up here, you have the limit of 2 minus 3x, and you're trying to find what is going to be the limit when x approaches 5. Well, simply knowing that this is going to be a continuous function, plug in your 5. So when you plug it in, you get 2, not plus, minus 2 minus 3 times 5. Well, this is going to be 15. So 2 minus 15 gives you a negative 13. That's all you have to do. The limit for number 1 is going to be negative 13. And you're going to do the same thing for your number 2. You're going to simply plug this in. We know this is going to be a continuous function at least at the point of interest. Now, it doesn't have to be continuous everywhere. Remember, we're going to be checking for continuity at the point. And to do so, we're plugging in the point. Not all points, the point. So by doing this, we're going to have 3 plus 2 over 3. And that gives us a 5 over 3. Now you know that this is not a continuous function. There's going to be a point in which it doesn't exist here. But we're not interested in that. We're only interested if you're continuous at the point we're asking about, a 3. And we are. So this means this is going to be the limit of this function at this point. And lastly, your constant. Your constant is just going to be equal no matter what x you have. So it doesn't even matter what this is. You can change that from an 8 to 100. You can change it to negative 50. It doesn't matter what this x is. You're just going to always be what that constant value is, your 7. So as you see, your continuous functions are going to be very easy to find their limits. And when I say continuous, I don't mean continuous everywhere. We're checking for continuity at the point of interest. If you have that, simply plug and chug and you are done. So let's jump into what happens when we have an indeterminate form outcome. Let's say we're given this question here. We are trying to find the limit as x goes to 4 of your function x squared minus 16 all over x minus 4. And when we do so, remember our first step is to plug in your number. You want to check for continuity at that point. What do we get? So we're going to have 4 squared minus 16 all over 4 minus 4. And what's 4 squared? That's 16 minus 16 over 0, and this is going to be 0 over 0. This lets us know that we have our indeterminate form. We can't stop here. This is not our first case where this is going to be continuous at this point. So when checking for continuity at the point and you get an indeterminate form, that tells you that you have a hole at this point. You have a removable discontinuity. So you simply have to simplify your function. Let's simplify this so that we can remove that hole and then proceed with our limit. Now I'm saying simplify because this is going to take one method of simplification, but you may have a function that requires a completely different mode of simplification. We're going to be factoring this out, but you may have something vastly different, but the steps are going to be the same. Simplify this as much as you can to try to remove that removable discontinuity. So when we factor this, we're going to have what? X squared minus 16 factors into, let's write this again, the limit as x goes to 4 of x minus 4 times x plus 4 all over x minus 4. Now we factor this out. Let's remove what we can. X minus 4 is on top and bottom, so we cross those out, leaving us with the limit as x goes to 4 of x plus 4. Now we've already talked about in my previous video on continuity that the limit of x plus 4 is going to be how this is going to react everywhere else except the hole. Now if you hadn't seen that video on continuity and limits, you can check it out right up here. But this is going to be the behavior of this function everywhere but at 4. So it lets you know that the limit is going to be simply what does this equal at 4. So simply plug it in. That's going to be 4 plus 4, which is 8. The value of this function at this point is going to be what the overall limit of this function is. So once again, the goal for indeterminate form is to remove the removable discontinuity and then start anew. Start from scratch, checking for continuity at the point and see what you get. So let's jump into our next section in which we cover our third outcome. When you have some number over 0, what do you do next? So let's say we had this function here. We're trying to find the limit as x goes to 0 of our function x plus 2 all over x. Now, this may look a little familiar. We had this exact function in our second section for today. However, this is a different limit because now we're approaching 0. And when we approach 0, something different happens. But let's see if we're continuous at the point. Remember, check for continuity at the point and see what we get. So when we do so, we're going to plug in 0. So it's 0 plus 2 over 0, which gives you 2 over 0. Now this is not the first outcome, right? This is not an acceptable number. You don't have 2 over 0 and say, I know what that is. This is not acceptable. We also are not in our indeterminate form, which means that it's not necessarily a simplification process. For some teachers, this may be enough to say that your limit does not exist. And for them, that's perfectly fine. You might not necessarily need to go any further than this if your teacher doesn't require you. As long as you have some number over 0, you can say this limit does not exist, and that's good. But some teachers actually want you to go a little bit further, because does not exist may mean two different things. It may mean that it truly doesn't exist, or it could mean that your function actually has a limit that goes to either infinity or negative infinity. And obviously you know that these are not actual numbers, hence the does not exist. But these are two different meanings for does not exist. If your teacher requires you to go a step further, then you can't just stop here. You got to do a little bit more work, and that little bit more work is going to be looking at your left hand limit and your right hand limit. So let's say we had the left hand limit as x approaches 0 from the left. We have x plus 2 over x. Now, x approaching 0 from the left means that we're negative and we're getting closer and closer and closer to 0. I say pick 2 points. Pick 2 points from the other side of 0. One that's a little bit further out, but not too far, but let's say a little bit further out, and you're getting closer and closer to 0. So let's say we're going to do something like this. We're going to try -1 and a -1/2. These are going to be our two numbers that we're going to try. -1 and -1/2. Both of these numbers are going to be on the other side of 0, but they're getting closer to 0 from the left. So let's start with -1. When we plug in -1, we're going to get the following. You have -1 plus 2 over -1, and this is going to be a 1 over -1, which gives you a -1. How about when you plug in your -1/2? You're going to have the following. You're going to have -1/2 plus 2 all over -1/2, which means that you're going to have a 3/2 over -1/2. And of course, you can rewrite this as 3/2 times 2 over 1, -2 over 1, that cancels out, which gives you a -3. So as we're approaching 0 from the left, starting from -1, go into -1/2, and you can keep this up. You can check more values, but let's say you're doing just these two. What's the behavior? You're going more negative, right? You're going more negative. Now we already know that we're going to be going to either infinity or negative infinity. You have to go to one of those two. So this is letting you know the general pattern that you're going to be having to follow. So are you going to infinity or negative infinity? You're going to go to negative infinity. So the limit, the left hand limit, so left hand limit is going to be negative infinity. Let's try the right hand limit. For your right hand limit, you have the same thing, except you're going to be approaching from the right, and you can do the same thing. So we can start at 1 and go to 1/2, doing the same thing. So when we plug in 1, we see that we're going to have 1 plus 2 all over 1, which gives you 3 over 1, which is 3. Now we're going to plug in our 1/2. So when we do that, we're going to have 1/2 plus 2 all over 1/2, which gives you a 5 over 2 all over 1/2, which we know we can rewrite 5 over 2 divided by 1/2 to be that here, that cancels out, and we're going to have 5. So I'll ask you again, what's the pattern here? Are we getting more negative? Are we getting smaller? No. We're actually getting larger, going from 3 to 5. We're starting at 1 and we're going closer to 0. Starting at 1 and we're going to a half, but we're going from 3 to 5. We're getting larger, which means that our right-hand limit is going to equal positive infinity. Well, what does that mean? That means that our right hand and our left hand are not actually shaking here. They're not going to equal. And when our right hand limit doesn't equal our left hand limit, that truly means that there is no overall limit. This is our infinite discontinuity, where we have a vertical asymptote at 0. Now, if your teacher asks you to go a little bit further, this is what you're going to have to do. Find your left hand limit, find your right hand limit, and see, do they equal? If they equal, say either positive infinity if they equal positive infinity, or negative infinity if they equal negative infinity. If they don't equal, then truly say it doesn't exist. That's all you have to do if you're given that third outcome of some number over 0. So I hope you were able to follow along with today's video and help you understand how to evaluate the limit of your function at a particular point. However, if you have any questions about what we saw today, or even your own homework, you can put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.